All right, so you've gotten your feet wet with Terraform. You wrote a script, it works great for one server, maybe two, but then the boss comes in and says, hey, we need 100 of these. Suddenly that feeling of success turns into a little bit of dread, right? How do you actually get from a simple script to something that's truly robust and scalable? Well, that's exactly what we're going to break down today.
And really, this is the core of the problem, isn't it? See, going from one server to 100 isn't just about writing 100 times more code. No way. It's about a complete shift in your mindset, a whole new way of thinking about how you build and manage your infrastructure.
I mean, let's be honest. We've all been there. You need a second VM. So what do? You copy the code for the first one, tweak a few values, hit Terraform apply, and boom, you're done. But then you need a third and a fourth, and before you know it, you're just drowning in duplicated code. A simple change becomes this massive, error-prone nightmare. Yep, that's the copy-paste trap, and we've got to escape it.
So you see, the real enemy here isn't the code itself. It's the complexity that spirals out of control. And to beat that, we've got to start thinking less like scripters and more like architects. So we're going to go on a little journey today, from the micro to the macro, starting with the absolute smallest, most fundamental building blocks you can use in Terraform.
Okay, so our journey starts at the micro level. We're talking about shaping our raw materials. Think about it. Before you can build a wall, you got to make sure your bricks are all the right shape and size, right? Well, in the world of Terraform, our tool for shaping that raw data is the for expression. Now, let's get really clear on what this thing does. A for expression is basically a transformation engine for your data. The most important thing to get in your head is that it never creates infrastructure. I'll say it again. It doesn't build a server. It doesn't create a database. All it does is take a collection, like a list or a map, and it reshapes it into the exact format you need for the next step. So here's a perfect everyday example of this data shaping in action. Let's say you've got a simple list of environment names, A, B, and C. But wait, your company has a strict tagging policy that says they all have to be uppercase. A for expression is your best friend here. It can instantly transform that list into A, B, C, making sure your data is perfectly prepped before you even think about creating a resource with it. All right, our data is shaped. The bricks are ready. Now we can move up a level to what I call the meso level. This is where we start laying those bricks down in neat, repeatable rows. And this is a big shift, because now we stop just shaping data and we start creating actual resources. The tool for this job? It's for each.
Now, for each is a totally different beast from a for expression. It's called a meta argument, which is just a fancy way of saying it's a direct command to the heart of Terraform. You're basically telling the Terraform engine, hey, listen up. For every single item in this collection I'm giving you, I want you to spin up a separate, unique instance of this resource. This, my friends, is the engine that lets us build at scale.
Let's see this in practice. Imagine we give for each a simple set of region codes, say US, EU, and AP. With that one instruction, Terraform will go out and spin up 3 completely separate S3 buckets, one for each region. Think about that. We wrote one resource block, but we got 3 distinct, independently managed pieces of infrastructure out of it. I mean, that is just some powerful efficiency right there. Okay, so this is probably the #1 question that trips people up. For each, they sound so similar, they both use loops, so what's the deal? When do you actually use which one? Let's put this confusion to rest and make the difference crystal clear. It all boils down to this table. Just look at the primary role. For each creates instances, it builds things. For, on the other hand, just transforms values. It shapes data. And that single difference tells you everything else. It tells you where you can use them. For each goes inside a resource or a module block, where you build stuff. A for expression can go anywhere you're defining a value, like in a local or an output. The outcome is the final nail in the coffin. For each gives you actual new infrastructure. For just gives you a new, reshaped list or map. So we've shaped our data with for, and we've built rows of resources with for each. Now it's time to zoom all the way out to the macro level. So how do we package up entire architectural patterns, I'm talking a fully configured web server or a whole network segment, into something we can reuse over and over again? The answer, of course, is modules. If for each built rows of bricks, modules are like entire prefabricated walls. So what is a module? Simply put, it's a self-contained, reusable package of Terraform code. The best way to think about it is like a standardized blueprint for a piece of your architecture. It's something you can grab off the shelf and use again and again in any project that needs that component.
And while we're on the topic, it's really helpful to know the lingo. You'll hear about the root module. That's just your main project directory, the folder where you're actually running Terraform apply. And a child module, well, that's any of those reusable blueprints that your main project calls on. It's a really simple parent-child relationship, but understanding that distinction is absolutely key to keeping your code organized.
So, you might be asking, why even bother with all this module stuff? Well, the answer is huge. It's because modules bring battle-tested software engineering principles right into your infrastructure. You get reusability, which means you finally stop repeating yourself the dry principle. You get abstraction, so you can hide all the messy details behind a super simple interface. And you get consistency, making absolutely sure that everything is built to the exact same standard every single time. And check out this real-world example because it just says it all. Imagine this. Instead of every single dev team trying to figure out how to configure monitoring, security tags, and all the right IAM roles, one central team just built a standard, company-approved module. Now, a developer can get a fully compliant, secure server just by providing a couple of input variables. That is the incredible power of abstraction in action.
Okay, let's pull all these threads together. We've gone on this journey from the tiny, shaping one piece of data, all the way up to packaging an entire chunk of our architecture. And what's really important to get is that this progression, it's not just about learning a few new Terraform keywords. It's about fundamentally changing how you think. It's about adopting a true infrastructure as code mindset.
So here it is, the path to truly scalable infrastructure. It's 3 simple steps. 1. You start at the micro level, using a for expression to shape your raw data. 2. You move to the meso level, using for each to build multiple consistent resources from that data. And finally, 3, you package that whole repeatable pattern into a module. That's the macro view, so it can be reused forever. Micro to meso to macro. Shape, build, package.
And if there's one thing you take away from all this, let it be this quote. Thinking of Terraform modules like functions in a programming language is the perfect mental model. It's exactly right. They take inputs, they perform some logic, and they produce outputs. And when you think that way, you can build your infrastructure with the same discipline, the same elegance as a really well-written piece of software.
Which really leaves us with one final, crucial question you have to ask yourself. Is your infrastructure just a bunch of scripts, or is it actual real software? Because when you embrace this structured approach, from shaping data with for, to building with for each, to packaging with modules, you elevate your craft. You stop being just a scripter, you become an engineer. And that choice, well, that's up to you.